guys, we're going to go ahead and start talking about 2.3 today here, and it's going to involve some scientific notation. Now, I'm quite sure that you guys have heard about scientific notation before. You've probably seen it, but we're going to go ahead and expound on this a little bit and talk about what it is that we need to do in terms of performing some operations in scientific notation. But before we can do that, we first of all need to understand what our goal is today and what scientific notation is. So, in 2.3, Exploring Scientific Notation, our goal today is to read and write numbers in scientific notation and recognize whether a result in scientific notation is reasonable. Okay? Does that answer make sense, in other words? So right down here, we've got some vocabulary, and scientific notation is really what we're going to focus on. Hang on a second, I don't need this down here. There we go. All right, so, quickly here. Our definition of scientific notation says a number written as a product right here meaning multiplication, a product of a decimal that is greater than or equal to 1 but less than 10, and then that second number is a power of 10. So as an example right here, when they say that first number is a number greater than or equal to 1 but less than 10, I might have an example of like maybe, I don't know, whoops, didn't want that big of a font, hold on. I might say something like 6.4. That first number is going to be any number between 1 and 10. All right, and then they say that that second number that we're going to multiply it to, it is going to be some power of 10. So I might say it's times 10 to the third. Okay. Now the thing that I want you to understand in this section too, we're also going to look at a situation where exponents can be negative. So another example may look like this, something like maybe 4.1. Again, that first number is between 1 and 10. Can be 1, cannot be 10. And then maybe times 10 to the negative 4. Now you may have talked about this stuff in a science class before, but really scientific notation is used to express very large numbers, numbers that are really, really long, like millions and billions of dollars that I don't have in my bank account. Or they're also used to write numbers that are really, really small. You might be something like 0.00000000000. Okay, that's enough, and then you get the point. There's some numbers after that. So we're trying to make long numbers shorter by writing them in scientific notation. All right. So now we know what this looks like here in terms of scientific notation with this first number right here, a number between 1 to 10. And our second number right here is a power of 10. Let's go ahead and look at example 1 now. Okay. In example 1, our job is to write numbers in scientific notation. Okay. We have numbers that are written as decimals to start with. All right. Now, guys, all of these numbers are going to be numbers where they may or may not fall between 1 and 10. Most likely, they're going to be outside of that range. Okay. In these examples, your job is to do this, and I'm going to zoom in here on this first one a bit so I can see this better and write. But the first one that I'm going to look at here is the following value, 250,640,000. Okay? That's about what the Powerball is worth right now. Our job is to write this in scientific notation. In other words, I want this first number to be between 1 and 10. Okay? And then the second number to be a power of 10, which I'll write as times 10 to the a value. Okay? So how the heck does this work? Well, quite easily here, really. All right? What you want to do is you want to draw a line somewhere that's going to insert a decimal to make this a value between 1 and 10. So right here in example A, I'm going to go ahead and draw a line right here between the 2 and the 5. If I would place a decimal right there between the 2 and the 5, you would have 2.5. Okay, now the point is this. You have to go ahead up to the last digit that's not a 0. So in this case, I would have to include the 0, the 6, and the 4. Stuff that ends in 0, totally irrelevant to put in scientific notation. So I'm going to write 2.5064. Question is, do I need the zeros at the end? You could put them there, but I'm telling you, you don't have to. Now, anytime you insert this decimal, you need to count the number of digits either to the left or to the right of it. Okay, you've got the 1 digit to the left. That's what you want. So I want to count the number of digits to the right. So as I count, I've got 1, 2, 3, 4, 5, 6, 7, 8 digits after that. Okay? Since my number is a value bigger than 10, your exponent will always be positive. So maybe we should make a note here at the top of this. Okay? I'm going to say any number bigger than 10, I'll put it right over here. Any number larger than 10, which I'll write any number, this stands for greater than 10, comma, then your exponent will be positive. Okay? So as I look at this number right here, 250,640,000 is clearly a number greater than 10. So what I'm going to say here is the following. Go back to my example. In the situation where I put the decimal between the 2 and the 5, and then I put a 064 after that, I counted 8 spots right here. And since that number is a value larger than 10, I simply say that this is 2.5064 times 10 to the 8th power. Okay? What it would mean is take this decimal and move it 8 places to the right. Now once I got past that 4, I'd have to add some zeros. And in that case, there were 1, 2, 3, 4 zeros to add there. Okay? So, scientific notation on part A is going to be 2.5064 times 10 to the 8th power. And ask yourself the question, is that first value a number between 1 and 10? Well, 2.5064 falls between 1 and 10. Is the second number a power of 10? Well, you have 10 to the 8th, so you betcha. Okay? All right, so let's look at part B. Part B then is this. I always ask myself the question, is the decimal I'm dealing with, first of all, a number bigger than 10 or a number smaller than 1? Okay, this is a very, very small value, something smaller than 1. So back in your notes, if you'll take a look on that right side, where I said any number greater than 10, your exponent's going to be positive, your other rule to maybe follow is this. Any number that you start with in decimal notation that is less than 1 will have an exponent that is negative. Okay? So this decimal in part B, 0.000039, clearly a number less than 1. So let's see how we can write that in scientific notation. So I go back to part B here, and I'm going to look. I'm going to say, okay, where could I put a decimal in this value to make that a number between 1 and 10? All right? Now, I would say, well, let's put the decimal right here between the 3 and the 9. That would mean 3.9. Now, I've only got one number to the right, so that's good. Like I had one number to the left over here, that was good, so you're going to count the long way. So right here, you want to go all the way to the left where the decimal point is. Okay? Now, since I went right over here, I had 8 as a positive exponent. So in this situation, we're moving to the left. That's simply going to mean that you have a negative exponent. So I'm going to count my spots. I want my decimal between the 3 and the 9. I'm going to count 1, 2, 3, 4, 5 zeros out in front until I get to my decimal point. Now notice, once I got the 3 out front, I didn't put all those zeros out front. Just like in part A, I didn't include those last zeros. Part B does not leave those leading zeros in scientific notation. So again, I counted 5 to the left of where I put my decimal. This becomes 3.9 times 10 to the negative 5. Okay? All right, so let's take a look at part C. See if we can't kind of clear up any questions you may or may not have at this point. Okay? So here we roll. You guys should feel sorry for me. I'm sitting in an in-service missing one of my favorite classes to teach. All right. Next value is 25,000. So the question becomes this: where am I going to put that decimal point? Or maybe I should even back up and ask this question. Is the exponent in scientific notation going to be positive or negative? Okay? Now, third hour, I know Ezra's going to tell me it's positive. All right? Sixth hour, boy, in sixth hour, I'm going to guess Lauren's going to tell me it's positive as well. All right? But again, where's that decimal go? Well, I'm going to put it between the 2 and the 5, so I'm going to call it 2.5. Do I need to include the rest of the zeros at the end? The answer is no. I'm going to count to the right. How many spaces have I taken up? 1, 2, 3, 4. So this will be 2.5 times 10 to the 4th. Very simple there. Okay? Likewise with the next one. Is that number in letter D, a number that's larger than 10 or smaller than 1. Well, it's a number that's less than 1. So I already know by rule my exponent at some point has got to be negative. So where do I want to insert a decimal where my first value is between 1 and 10? Well, I would put it right here. Okay, I would call this 4 point. Now I got to put 0, 0, 2, but after this 2 right here, all of these are 0, so I don't really need to include them in that first value. All right. Now, where I've placed the decimal between the 4 and the 0, I'm going to count back to the left to where the decimal point really is. And in this case, counting left, I counted left 1 unit, so I call this 4.002 times 10 to the negative 1 power. All right? Okay, so that's how you take anything in decimal notation and put it in scientific notation. Next part of this is going to be doing just the exact opposite. And example 2 is really the easiest thing in the world. If you know your right from your left, you'll be in good shape. Okay? What I will tell you is this. If your exponent is positive, that's how many places you're going to move the decimal point. If your exponent is positive, that's how many places to the right you'll move the exponent. Okay, and I'll show you that in a second. And get this other part down. If my exponent is negative like it is in part B, well, you guessed it. If the exponent's negative in part B, a negative exponent is going to mean move your decimal point left that many units. Okay? So right here in this first example, I have a number in scientific notation. It's in scientific notation because the first value is between 1 and 10, and the second value is a power of 10. All right? Oh, I look at my exponent right up here of 8. Since my exponent is positive, it simply means move your decimal 8 places to the right. So in this number, I can move 1, 2 places, puts me after the 5. Once I get that past the 5 like that, well, your job simply is to go ahead and fill in the final 6 places. And the placeholders are simply going to be 0. So I'm going to have 3, 3, 5. That's 2 jumps right there. And then I'm going to have to add 6 more zeros to say that I've moved 8 places. So let's go ahead and do that. 1, 2, 3, 4, 5, 6. So the value 3.35 times 10 to the 8th in scientific notation is the same as 335 million in decimal notation. All right? Same thing in part B. You're just going to move this left 7 units. Okay? Once you move left and clear the 5 right there, you're going to have to put in 6 more zeros to get to the 7th jump. Okay, so 1 jump is to precede the 5. You would need 6 more to make 7 total jumps. So you're going to have point 1, 2, 3, 4, 5, 6, 5, 5. And it makes sense. Your value here in decimal notation, it's a value smaller than 1. Okay? And up here, to begin with, the exponent was negative already. So you know you had to have a value less than 1 when you did that. Okay, questions to this point? Now would be a good time to pause this, ask Mrs. Foss if there's any questions. Okay, moving on. Next page here then. Take a look at the second page. See what we've got up top here. Got a few of these that are on your own. I'm going to have you go ahead and try these on your own. Okay, and I'll just simply put the answers up here real quickly. So if Mrs. Foss would pause right here and let the class figure this out, go ahead and do so. When you guys are done with your solutions of all 6 of these on your own, then check with a neighbor. If you guys disagree with something, talk about why you disagree and make sure that you guys come to a consensus on all this. I'll give you about 2 minutes to do this. All right? Ready? Go. First one, right there, 3.4257 to the third. I put my decimal between the 3 and the 4. I had to move right 3 places to where the decimal really is. That's why I have a +3. My second one, I'm going to put my decimal between the 2 and a 0, so I call this 2.06. And I would have to move left 2 places to where the decimal really is. So that means times 10 to the -2. All right? If you have questions, let someone know. Next one. Put my decimal between the 4 and the 0. And then the decimal point's really here on the end. Even though it doesn't show up, there's really a decimal point right there. So I'm going to call this 4.0563 times 10 to the, there's 1, 2, 3, 4 digits where I put the decimal, 4 digits after where that decimal would be, so times 10 to the 4th, okay? All right, so if you got those 3 right, give yourself a pat in the back. Bottom ones, I expect everybody to get right. It's just simply moving the decimal left to right. In the first one, you're going to move the decimal 5 to the left, okay? So one jump precedes the 1, which means you'd have to put 4 zeros in front. So it'd be 0.00013. My next one, positive 4 means move that 4 to the right. So here's 1 jump, 2 jump, 3 jump. I'm going to have to put a 0, 1 0 at the end of this. So this will be 64,570. Right? And then my last one here real quickly. Again, exponent's negative, indicates to that, move it left. All right? 1 jump precedes the 5, which means I've got to make 6 more jumps. So I'm going to accommodate with 1, 2, 3, 4, 5, 6 zeros, and then a 5, 5. All right, so that part of it I think is pretty easy. If there's anything that's difficult, it's going to be example 3. And I think that if you just pay attention to the rules I give you, you'll find that this is pretty darn easy. All right? Now, I'm going to rewrite these problems so I have some room to work. But as I'm rewriting them, you'll want to make sure you put the work down for it. Okay? I'm going to kind of put some rules down here first. All right? You're going to want to say something like this. Example 3 says following, simplify and put in scientific notation. Now what that means is this. We got to carry out an operation. Here we're going to take 220, a number in decimal notation, times a number in scientific notation. Now what I'm going to tell you to do here is this, all right? Make sure all numbers, or I guess I should say step 1, okay? Whoops, hold on. Better put a number by the step. Step 1, okay? Turn all your numbers into decimal notation first. Okay, so you might want to write that up here, but allow yourself some room right down here to do letter A and letter B and letter C, all right? So, letter A, I'll rewrite it here real quickly. It simply says 220 times 6.4 times 10 to the 5th, okay? And again, we're going to put our answer in scientific notation in the end, but I'm stressing to you that we should put everything in decimal notation first, and I think you'll understand why as I work through this, okay? So right here, my number in scientific notation is 6.4 times 10 to the 5th. My job here is to turn that to a decimal. So this is going to become 220, that's already in decimal notation, times, okay, in this here I've got to move that decimal 5 to the right. So I've got 1 jump past the 4, which means I've got to put 4 more zeros. Okay. So what I've got here is 220 times 640,000. Okay, so that was step 1. Both numbers are now in decimal notation. Okay, no problem. I'll go back to this page right here, step 2. Okay, step 2. We're just going to evaluate it then, all right? We're going to evaluate that product that I have of 220 times 6.4 times 10 to the 5th. So if I go back to my problem here, oh, let me pull up my calculator. Hold on 1 second here, gang. Tools, more tools, calculator. Okay, so what I want to do here essentially is say, okay, let's take 220 times that decimal that I wrote out of 640,000. It equals in this, and there's my product right there. I get, it looks like, oh, I got to write this down. I think this will go away, possibly. Well, let's see. 100. Yeah, it did. Gosh darn it. Hold on. Let me bang that number. How many zeros do I have in the end? 1, 2, 3, 4, 5. So 140.08. 1408. And now I can't even remember. My CRS is kicking in. Mrs. Foss, if you're not sure what CRS is, it means can't remember stuff. All right, 1, 2, 3, 4, 5 zeros on the end of this. Okay. So this is my step 2. I've evaluated. So I'm going to put some commas in here to kind of separate this out a little bit. We've got 140,800,000. Now keep in mind, our job is to put this stuff in scientific notation, okay? So once I've gotten to this point right here, I've got to put this in scientific notation. So my job simply becomes the following. And I'm going to back up to this last page and put your rule down, and then I'll tell you. But step 3, and I'll kind of put it like this, put solution, that big number that we had on the previous page, I put that solution in scientific, I'll abbreviation, scientific notation, and I'll just abbreviate that, all right? So step 3, put your solution in scientific notation. So right here we go. Looks to me like my decimal would fall between the 1 and the 4 right here. Okay, 1.408. Do I need all the zeros after the 8? The answer is no. Then, the decimal point's really way on the end. Where I have the decimal point or want the decimal point between the 1 and the 4, how many places do I have to count to get to where the decimal point really is right here? Well, looks like 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8 places, so I'm going to call this times 10 to the 8th. And that, my friends, is your solution of that product in scientific notation. So just to recap, turn everything into decimals, perform your operation, get an evaluation. Once you have that evaluation in decimal notation, simply put it back into scientific notation. All right. I'm going to keep the current color scheme, and if this computer dies on me right now while I'm doing this, I'm going to be upset, because it's about 9 o'clock and it's way past my bedtime. All right, so let's try these last 2 here. I'm going to put the work up on another sheet like I did in this last one. Not going to talk through it very much. You just kind of follow along. All right. So here's my next one, letter B. Whoops. All right, so likewise, guys, I'm going to turn this one scientific notation into decimal notation. So I got to move the decimal 4 to the left, so that'll be 0.00072. Okay. At this point, I'm going to go ahead and pull out my calculator, multiply those 2 decimals, so we'll go 45 times 0.0072. Oops, I messed that up. Let me reset that. Clear that. 45 times 0.000. There we go. 72. And I get 0.0324 as my solution. So 0.0324 is my decimal solution. So to put this in scientific, I'm going to go between the 3 and the 2 and call this 3.24 times 10 to the negative 2. Okay, excellent work, guys. Excellent. All right. Mrs. Foss, pause it right here. Have them try this third one on their own, see if they can get it. I'll put the answer up here in a second. All right, my third one here, guys. Let me go back and look. Part C says the following. It says 3.8 times 10 to the 8th divided by 160,000. Okay, I'll see if I can remember that. Well, you know what? I'm just going to put it right here. This will be 8 followed by 7 zeros divided by 160,000. Those are my 2 values in decimal notation first. So 380 million divided by 160,000. Okay, I have a pretty good idea what that is, but I'll go ahead and confirm it here calculator-wise. So I'm going to take 380 million. I'm sorry, did I get that right? Yeah, I do. I do. Haley, be nice. And I'm going to divide this by 160,000 now. All right, and when I do this right here, there's my answer. Ooh, something's wrong. Something's definitely wrong, isn't it? No, that's all right. 2,375. Nice decimal, okay? Put that in scientific then. That's where your decimal would lie, so I call it 2.375. That first value is between 1 and 10, right? Okay, and then finally I would have to move 3 to the right to get to where the decimal really is. So this would be times 10 to the third. I'm going to double check this one more time just to make sure I've got that right. I've got 380 million divided by 160,000. Yep, feeling good about that. All right. Assignments you're going to get, would really like to try and get by tomorrow. However, I understand if there are questions at the beginning of class. Get your quick quiz done. That's part of your packet right now. And your book page is also attached to your packet. Again, don't sweat. If you have questions, shoot me a text, shoot me a snap, Snapgram or InstaChat, whatever you want to do. But hopefully this has helped today. And Mrs. Foss, if I've driven you nuts, I sincerely apologize. All right, gang, you guys have a good day and be good to my sub.